Good day again. So, I am here to discuss my last topic, which is the panspermia. So, panspermia is a hypothesis that suggests life or the ingredients necessary for life could be distributed throughout the universe by natural means such as comets, asteroids, meteoroids, and cosmic dust. According to this hypothesis, life may have originated on one planet and then separate to other celestial bodies, either within the same solar system or across interstellar distances. So the term panspermia comes from the ancient Greek words pan meaning all and sperma meaning seed. So this theory proposes that life exists throughout the universe and is distributed by space dust. So we have here the several variants of panspermia hypothesis proposing different mechanism for the distribution of life. We have here the Letospanspermia. This variant suggests that life could survive within rocks blasted off a planetary surface by impacts and travel through space until they land on another celestial body. If conditions are suitable, life could then emerge and thrive on the new world. So, example of this is such as from Mars to Earth via meteorite impacts. We have also Regiopanspermia. This proposes that life could be spread through space by radiation pressure from stars or other astronomical phenomena. This mechanism could potentially allow microorganisms or organic molecules to travel vast distances across interstellar space. So, this hypothesis suggests that life could survive the harsh conditions of space and be transported between star systems by radiation pressures or in the form of dust grains. Also, we have the directed panspermia. It is a more speculative variant of the hypothesis, suggesting that life could be intentionally seeded on other planets or moons by an advanced terrestrial civilization. Proponents of this idea argue that the deliberate dispersal of life could be a way for intelligent beings to ensure the survival and proliferation of life in the universe. So while panspermia remains a hypothesis and has not been conclusively proven, questions it raises intriguing questions about the possibility of life existing beyond Earth and the potential interconnectedness of life across the cosmos. Evidence in support of panspermia includes the discovery of extremophiles, organisms capable of surviving extreme conditions on Earth, as well as the detection of organic molecules in meteorites and interstellar dust clouds. So challenges remains in demonstrating the feasibility of panspermia as a mechanism for the origin of spread of life. So panspermia offers a thought-provoking perspective on the interconnectedness of life and the potential for life to exist beyond the confines of our own planet. While its validity is still a subject of scientific inquiry and debate, The concept of panspermia stimulates explorations and discussion about the origins and distribution of life in the universe. So, speaking of interstellar space refers to the vast expanse of space that exists between stars within a galaxy. That is the region of space that extends beyond the influence. So, speaking of interstellar space, it refers to the vast expanse of space that exists between stars within a galaxy. It is the region of space that extends beyond the influence of any individual star's gravitational fields and encompasses the space between star systems, as well as the space within galaxies that is not occupied by stars, planets, and other celestial bodies. So, the characteristic of interstellar space is low density, interstellar medium, interstellar extension, interstellar travel, and interstellar communication. Interstellar space remains a frontier of exploration and discovery, holding clues to the formation and evolution of galaxies, stars, and planetary systems, as well as inspiring scientific inquiry into the possibility of life beyond our solar system. So, let us let us go to the pieces of evidence. First is we have meteorites or meteors. These are the space rocks that fall to Earth's surface. Meteorites are the last stage in the existence of this type of space rocks. So the meteorites are rocks that have fallen to Earth from space, contain organic compounds such as amino acids, sugars, and nucleobases. So these organic molecules are the building blocks of life and suggest that the ingredients for life are present in space and could have been delivered to Earth via meteoritic impacts. So some meteorites contain traces of water, both bound within minerals and as hydrated minerals. The presence of water in meteorites indicates that water-rich asteroids or comets could have delivered water to Earth during the planet's early history, providing the necessary solvent for life to emerge. Then in meteors, the panspermia, panspermia includes in the process of panspermia includes in the searching for life elsewhere in the universe by via meteors, as what I've discussed earlier in the topic of searching for life elsewhere. So meteorites provide potential mechanism for panspermia. The hypothesis for life could be distributed throughout the universe by natural means. Microorganism or organic material could survive within meteorites during their journey through space and potentially seed life on other celestial bodies. Next is extremophiles, are organisms that thrive in extreme extreme environments on Earth, such as deep sea hydrothermal vents, acidic hot spring, polar ice caps, and arid deserts. So the existence of extremophiles demonstrates the adaptability of life to diverse and extreme conditions, raising the possibility that similar environments on other planets or moons could also harbor life. The extremophiles also expand the range of environment considered potentially habitable for life beyond Earth, challenge traditional assumptions about the limits of habitability, and suggest that life may exist in a wide variety of extreme environments throughout the universe. So, also, the extremophiles serves as analogs for potential extraterrestrial environments. By studying extremophiles and their adaptations, scientists can gain insights in the conditions necessary to s- necessary for life to survive and thrive in extreme conditions elsewhere in the solar system or galaxy. Last is the interstellar dust. So, interstellar dust grains, which is its chemical composition, contain complex organic molecules including polycyclic aromatic hydrocarbons, amino acids, and carbonaceous materials. These organic compounds are thought to form in the interstellar medium and may contribute to the chemical precursors of life in planetary system. So interstellar dust grains scatter and absorb starlight, causing distant stars to appear dimmer and redder than they would otherwise. This phenomenon, known as interstellar extinction or reddening, provides evidence for the presence of dust in interstellar space and affects our observation of distant stars and galaxy. We all we Mrs. Miss Isparal already discussed it. Formation of planetary systems in the interstellar dust plays a crucial role in the formation of stars and planetary systems. Dust grains act as seed for the formation of larger bodies such as planets, asteroids, and comets through processes of accretion and gravitational collapse. So the evidences collectively contribute to our understanding for the potential of life elsewhere, life beyond Earth, and interconnectedness of the cosmos. So this highlights the diverse environments and complex chemistry present in space, providing insights into the origin and distribution of life in the universe. So, meteors, extremophiles, and interstellar dust provide pieces of evidence that supports the panspermia hypothesis by demonstrating potential mechanisms for the transportation of life's building blocks and organisms between celestial bodies within our solar system and beyond. So that would be all. Thank you.